Hello everyone. Today we are going to see a topic in CNC milling operation. Introduction. Computer numerical control. It is a mechanical tool that uses a computer program to control the movement of cutting tool. CNC milling are widely used in industrial because they produce accurate, complex and high quality component with very little human error. Now let's see what is CNC milling machine. A CNC milling machine removes material using rotating cutting tools. The workpiece is clamped on the table. The cutting tool moves along X, Y, and Z axis, controlled by using geometrical code and miscellaneous function code instructions. Now, let's see the main parts of CNC milling machine. First, the machine bed support the entire machine. Next, the spindle hold and rotate the cutting tool at high speed. Next, the work table hold the workpiece tightly during machining. The cutting tool remove material from the workpiece to produce required shape. Next, the control panel to enter and control the CNC program. Finally, the coolant system cools the cutting tool and workpiece and helps improve tool life and surface finish. These parts work together to produce accurate component. Working principle. Now let us see how a CNC milling machine works. First, create the component design using CAD software. Then, the design is converted into G code and M code using CAM software. Load the G code and M code into the CNC machine. The workpiece is fixed firmly on the machine table. Finally, the machine follows the program and moves the cutting tool automatically to produce the required component with high accuracy. Now let's see types of milling operation as shown in the image. First, face milling operation used to produce flat surface. Then, end milling operation used to produce step and profile. And slot milling used to cut narrow or wide slot and keyways. Then, pocket milling used to remove material from inside area. Finally, drilling operation used to produce round holes. Advantages. Benefits of CNC milling machine. High precision and accuracy can be achieved. Faster production. Less human errors. Excellent surface finish can be obtained. Also can produce complex shapes. Applications. Now let's see where CNC milling machine are used. In the automobile industries, used in cars, bikes, trucks and other vehicles for high precision components. In the aerospace industries, used in the aircraft, satellites and rockets for strong, lightweight and reliable parts. Also in medical field, used in medical equipments and implants, where accuracy and safety are critical. So, CNC milling is widely used where high accuracy and complex shapes are required. Limitations. Now, let's look at some limitations of CNC milling machine. The initial cost is high because the machine and its equipments are expensive. We need skilled operator and programmer to operate and program the machine. Regular maintenance is also required to keep the machine work accurately. Finally, CNC milling may not be economical for every small production quantities. So, CNC milling give high accuracy and production, but it also required high investment and skilled operation. Conclusion. CNC milling machines are essential in modern manufacturing. They provide high precision, speed, and consistent quality. They are widely used across many industries to manufacture complex components effectively. Now, let's see a practical CNC milling simulation after understanding some important codes used on the program. The codes are uploaded on the control panel. By using the code, the milling operation is performed. The workpiece is fixed on the table. After uploading the code to the CNC machine, the simulation is started. When the operator touches the play button, the machine starts working. At first line of the code is T20. Tool is taken from the tool home. The code T20 gets the facing tool first. Then the material remove operation is performed. The code G00 represents rapid movement of the tool without cutting. Then the code G01 represents the straight line cutting movement. Then the XYZ letter indicates the movement of table in the axis. And the hashtag number indicate these are variables. The phasing operation is performed until completing. Now the tool is changed after completing phasing operation. Then the new tool is fixed in the spindle by using the code T10, which indicates drilling tool. Then the drilling operation is performed. Then the code G83 is drilling cycle. It controls the drilling operation step by step. Then the code G80 represent cancel the drilling operation after the required holes are performed. After that, we can see the code G28, which means send the machine back to its reference or home position. Finally, M03 code represents the end of the CNC program. So these codes work together to control the tool movement, spindle, drilling operation, and overall machining process automatically. Then the machined product is removed from the table. Hence the CNC machine operation is successfully performed.